Hello, friends. Welcome to Akulmach Live, and I am CK. Today, we are talking about the interstellar space travel. You know that in order to survive as a species, we need to basically travel outwards, beyond Earth. I think there are a lot of initiatives being taken up to travel to Mars, but then Mars takes 6 months using the current technology, using the rockets that we have today. And return journey will take another 6 to 7 months. And the opportunity to return to planet Earth will arise within the 3 years. So the trip to Mars is a one-way or two-way ticket, which will start but then end after 3 years. So which is a very long time. So, how do we resolve this issue? Is basically improving our propulsion technology, and therefore there are a lot of technologies which are available today. And in this video, we are going to talk about 5 technologies, and I will rank them accordingly, which are most applicable and which are most suitable for this particular journey. So let's start with our first option, which is the chemical rockets. We have been using this rocket for quite some time, and the rockets looks like this. Usually the chemical reaction between the fuel propel the rocket. These are very common. Usually the fuel is liquid oxygen and hydrogen. We bring them together in a combustion chamber, and it generates a lot of heat, lot of lot of thrust, lot of power, and it also gives water as a byproduct. Steam is as a byproduct. So this is a rocket which is mostly used today. This kind of rockets are mostly used today, and they propel our satellites and our spacecraft up in the atmosphere and even to the moon. And these are not harmful to the environment also, because their byproduct is only water, steam or water, H2O. However, these kind of rockets require fuel, and that has to be put on board, and they consume very rapidly. And if you look at the rockets today, almost 95% of their weight is the lift-off weight of the rocket that comprise of the fuel itself. So by the time they reach the space beyond the in the lower Earth orbit, 95% of their fuel is exhausted, and only 5% is the spacecraft. And therefore, there is hardly any space left for humans or their cargo. So, and these are rather slow in terms of the kind of speed we need in order to reach far off places like Mars, of course, is quite far off, and beyond, which is Jupiter, etc. So, this is not a viable solution. However, this is the best solution to lift off. If you want to leave the orbit, leave the Earth's gravity and counter the Earth gravity, these are the rockets. Chemical rockets are the best option for the lift off. So I think the future technologies which I'm going to talk about today will be the most suitable rocket engines for high speed travel to other areas. All right. So this is the first one, which is the chemical rocket. Also, with regard to chemical rockets, I think they are, as I said, they are well suited. So you can actually start looking at manufacturing facilities up in the space, where you can actually assemble a huge rocket, a mothership, using the upcoming propulsion technology, which will be much more useful for faster travel between planets and interstellar travel. So next on our agenda is the nuclear pulse propulsion. Nuclear pulse propulsion, as this is a type of rocket, and you can see the nuclear symbol on the rocket. This rocket actually creates a reaction using fission engines. Fission is the type of nuclear reaction that we use in our nuclear power plants today. So it's like a bomb, but there is an exit on the other end. So they create a controlled fission reaction, and a stream of very energetic particle exit from the other end, one end of the rocket, propelling it in the other direction. Now, this is a very, very very potent reaction. You need a very small amount of plutonium or uranium based fuel, and so like 20 kgs or 30 kgs for the entire trip. So this technology will reduce the fuel weight on the rocket by many times. So you can make much larger rocket with a smaller engine, but it will have much more power than a chemical engine. At the same time, this is not the technology which we can use on Earth. Obviously, it has radiation, so this is not the technology that we can use to lift off from Earth. We would still need chemical rockets to lift off and then get into this rocket, which is completely made in outer space, and use this technology. This is cheap, this is reliable. Humans have a lot of experience in nuclear pulse propulsion, and this can be very easily constructed using the current day technology. All the components are already available. Scientists know how. More than 100 years of our journey we have already spent, and we have actually perfected the art of making the nuclear engines. However, lot of research is not being done because of the Geneva Treaty. The nuclear, so far, as of now, the nuclear reactions or nuclear experiments cannot be done in outer space. So nothing has been done in this area to develop this technology further. All right. So let's move ahead and let's look at the next propulsion technology on our list today, and that is the fusion rocket. Fusion rocket requires, as the name suggests, the rocket which actually fuses lighter elements like hydrogen to create helium and generate huge amount of thermonuclear energy. Now this is the next level. So far, on the surface of Earth, scientists have been trying to create a fusion-based nuclear reactor because this is clean energy. It does not leave anything harmful in nature, and you require only hydrogen, very little amount of hydrogen to generate huge amount of energy. And as you know, friends, the hydrogen is omnipresent gas. Even if there is nothing in the vacuum of space, you will still get hydrogen atoms. So you don't have to carry your heavy fuel, just like chemical rockets. You just have to carry small initial hydrogen, and then you can get a refill done in the outer space. Now, this kind of future rocket, this is not a reality yet. A lot of experiments being done on this. But if you construct a huge mothership out in the space fitted with fusion engines, then you have to just fuel the fusion engine with hydrogen, create thermonuclear reactions in their combustion chamber, and the jet will come out from the other side, propelling the rocket at very, very high speed. Because this is all based on the understood science. If the jet is coming out at very high speed, you will actually get very high speed of your rocket in the other side. So if you have this kind of an engine, this kind of technology being developed, then the trip to Mars will take only 4 weeks. Imagine something which is taking 6 to 7 months will take only 4 weeks to travel. So that if this kind of engine is viable, then the travel to Mars will also become practical. And therefore, this is the current technology. I mean, this can be done because fusion reactions have been performed in the laboratory environment. The only challenge is, we need a high magnetic. Instead of building a metal body to hold this thermonuclear reaction, we just need a very strong magnet to to basically make sure that the reaction is happening only in one direction, not in all directions. And this is a very safe reaction which allows safely to propel in the outer space, in the interstellar space, because these kind of rockets are very fast and can also take you to other stars at high speed. And as you know, friends, acceleration, by doing acceleration in the space, you can keep increasing the speed to a high magnitude of almost nearing the speed of light, and that will help you to go to other star systems within your lifetime. So you don't have to basically travel for 10,000 years, 20,000 years using the chemical rockets. You can actually make some of these advanced engines like uh, the fusion reactor, and then you can actually travel to interstellar objects. All right, let's move on to the next propulsion technology on our list today, and that is the solar sail rocket. So, as the name suggests, solar sail is a rocket which is something like this. It has a sail, just like the old ships used to have sail. And the way it works is that it actually gets the light coming from the sun. It has a huge sail basically. The light coming from the sun will actually strike the sail, and even though the light photons are massless particles, but then for some reason light has a different property. It actually has a momentum. When they strike the sail, it will impart the pressure onto the sail, pushing this aircraft or the spacecraft in the forward direction. So using this technology, which is very lightweight, there are no fuel required. You don't have to build very huge engines. All you need is a sail material, and you get then harness the solar energy for free. And since it is based on acceleration, so if you put your spacecraft in the space and let it gather momentum, the spacecraft it can be accelerated to almost 20% of the speed of light, very very fast. And once it starts moving at that speed, these are not relativistic speeds, but once the spacecraft is moving at that speed, then it will continue to move at that speed, leaving the solar system, going to say close by neighbor like Alpha Centauri. So this is another propulsion system which has been already tested, tried in various satellites, and they work. And within like 100 years, you can reach Alpha Centauri to colonize those planets there in the close by star system. So this is something which is very very practical, and the only challenge here is the material used for building the sail. It has to be quite huge, and it has to be made of very light material, and the material must be strong also, so that it does not get broken up or anything like that during the journey. So this is one viable, and once you don't get the pressure from the solar winds or solar light, once you reach very far off, then you can switch to fusion engines, still continuing with the acceleration. So these are combination of fusion engine and solar sails can also be a good combination. The third option with regard to solar sail is that the initial push can be provided by earthbound or a moon-bound lasers, very high energy lasers, which will then propel the aircraft to start the aircraft, and then the solar wind will take over and then continue the journey. So this is the good option using the current technology that we have and current knowledge. Let's look at the next one, and this is ion propulsion. Ion propulsion again is a very good design of rocket engines, and as the name suggests, ions. Basically, what happens is that you use the electricity to separate atoms from electrons, and then you have ions, basically positively charged nucleus and negatively charged electrons. And then you push these ions using magnetic field from a nozzle from the back of the rocket, so that when Newton's third law will apply here, when the ions are moving away from the rocket, they will actually push the rocket in the opposite direction. In the space, it doesn't matter whether ion is very small and rocket is huge, multi-ton, because even if the ion is small and it is moving out from the nozzle at high speed, the rocket will move in the opposite direction at equal and opposite speed. So this kind of engine is very very efficient, extremely efficient, and can reach the speed of almost 50%, can actually accelerate to almost 50% of the speed of light. So you can have combination of ion engine, because ion engine, when they start the engine, it will take time for acceleration. You can actually build a combination of solar sail. So within the solar system, use the solar sail to travel, and then switch on to fusion engine, and then subsequently also start your ions, because your ion engine, once it picks up the speed, it will continue to accelerate and then shorten the travel time to other star systems drastically. So you can actually become very practical space-faring species using the ion engines, and then travel to not only to Alpha Centauri but almost 100 light years away within your lifetime using the ion engine. So this is again already tested out technology. Some of the satellites are already, which are being sent to asteroids, are already having the ion engines, and these ion engines work. So this is something which is already very practical. Let's look at the last, the last option, and that is the antimatter rocket. Now I included this because this is being used by a lot of fictional material that we have today. Now, the very reason that antimatter rocket is a practical option, because this is a one step ahead than the fusion reactor. If you have an antimatter just mixed with that matter, and you get pure energy. There is the reaction itself will give you pure energy. The only problem here is that the antimatter material is very, very expensive. Whatever antimatter we produce in the various cyclotron experiments in our collider equipment will, even like a small amount, will cost trillions of dollars, because that is how we can produce antimatter on Earth, and then we cannot store it, because moment it interacts with the matter, it generates energy. So storage is a big problem. Nevertheless, the fictional the fictional material always use antimatter as a material to use to generate a lot of energy, so that you can use that energy to propel your rocket at warp speed. So I have included this because the antimatter matter reactions are well understood. Although even though we are able to generate some technology to power our rockets using antimatter, we do not know how to store them. We do not know how to keep the fuel so that we can actually use antimatter, small amount of antimatter, and mix with matter, and then generate our propulsion. So that understanding is not there, even though producing antimatter is very, very expensive. But we understand this very well. We have understood the technology quite well, and we can actually, if we are able to make antimatter on the surface of the moon, maybe the future tech will make it cheaper. And if we are able to power our rockets in the vacuum of space using antimatter, then we can actually attain very, very high, extremely high speed, and some of these rockets can actually achieve the relativistic speed, reducing the time to far off objects, because you're now traveling at almost the speed of light, but not reaching the speed of light, but almost the speed of light. And therefore antimatter can become reality in future, maybe 100 years or 200 years down the line. So friends, these are the 5 propulsion technologies which the humans understand completely, and we can use it for our interstellar travel. That means within the solar system to the outer regions, and also to nearby stars. And if you have any questions, if you have any comments, please feel free to send it across. Thanks for watching. I will catch you again in the next one.